Okay, so now welcome back, and now we're going to start tackling problems that involve unbounded intervals, or intervals that are open intervals. So open intervals, unbounded intervals, so that's what we're going to tackle now. And so now we're going to do an example, and we'll do a couple of examples of how we handle examples where we're dealing with either open and or unbounded intervals. So let's jump right in. So here we're going to deal with an open box, and so here's the situation. Let me get my marker. So in this situation we're dealing with the construction of an open box with a square base. Okay, and so what I'm going to do is label the box here. So it has a square base, so that means this and that side, are going to be the same. And it's going to have a height of, let's say, y. Now, they tell us, hold on, what do they tell us? They tell us that the volume, here we go. So the volume is 216 cubic inches. Okay, so now here's what they want to do. It says a rectangular box with a square base and open top and a volume of 216 cubic inches is to be constructed. What should the dimensions of the box be to minimize surface area of the box? What is the surface area, the minimum surface area? So we want to minimize surface area. Okay, now what is surface area? So let's get the formula. The formula for surface area, we'll call it S, is what? The area of all the sides. Well, it's open, so there's no top. So the area of each side is x times y times 4. So there's 4 sides. And then the bottom, the base, is just a square, so it's x squared. So we're going to take the 4 sides, so it's going to be 4 times xy plus the area of the base, which is x squared. Okay, now, but we've got multiple independent variables here, right? So we want to substitute in for y, and that's where the volume comes in, because they give us a constant volume. Well, what's volume? The volume is the length times width times height. So in this case, it's going to be y times x squared. So now we can solve for y, right? So then that tells us that y is going to equal 216 over x squared. And now our surface area formula becomes 4x times 216 over x squared plus x squared, which then becomes what? Well, this x is going to cancel with one of these x's, and so we get 4 times 216, which is 864. So we get 864 over x plus x squared. So there's our surface area formula. So now, a couple of things to consider is, what about x, the domain of this thing? Well, x can't be 0. Okay, because the volume is positive. So, it's greater than 0. So x can't be greater than 0. So x has to be greater than 0. Okay. But as x gets larger, y is going to have to get smaller, because they're directly proportional, right? Or jointly proportional. Okay. So x squared varies directly as y, or y varies directly as x squared. So because this has to stay constant, as one increases, the other one has to decrease. And so as x gets larger, y is getting smaller. So we could actually have, in this case, x can go on to infinity. So here's an example where we have an unbounded open interval. Okay? So now, here's the thing. We cannot reduce our problem to looking at a closed interval. There just is no closed interval that we can consider. Because if we could, then we could deal with finding the absolute value, or excuse me, the absolute minimum and maximum. But since we're dealing with an unbounded open interval, we can't do that. So how do we do this? Well, let's look at the endpoints. Right, so this is an open interval from 0 to infinity. Right, so now let's consider the limits. Let's consider what happens as the limit as x approaches 0 from the right of s. Okay, what happens? Well, what happens to this? This becomes 0. Well, what happens to this as it gets closer and closer to 0 on the right? So we're approaching inside the interval. Remember, inside the interval. So we're inside the domain. What's happening? Well, this is getting smaller and smaller and smaller, so this is getting larger, so this thing's going positive infinity. Okay, good. Now, what about going to infinity? Okay, so what's the limit as x approaches infinity of f of t? Well, as x goes to infinity, this is going to infinity, but this is going to 0. So this is also going to positive infinity. Well, here's where it gets interesting. So we've got a continuous function, right? So that's key. It's a continuous function on the domain from 0 to infinity. And we know that as you get closer to 0, it goes to positive infinity. And when you get closer to infinity, s goes to infinity. So what does that mean? It means that as x gets closer to 0, it's going up to positive infinity, and when x gets really, really big, it's going to positive infinity. What does that mean? It means that there has to be a point inside the interval, so there has to be an interior point such that there's a minimum point, right? And so that's what we're going to use. So now we're going to take the derivative, okay? So now, let's look at the derivative function. So we get s prime of x is equal to, well, this is just going to become negative 864 over x squared plus 2x. And we're going to set this equal to 0. Right? So now, if we set this equal to 0, what do we get? We get 2x is equal to 864 x squared, not lambda, x squared. And so now if I multiply both sides by x squared, I get 2x cubed is equal to 864. Okay. Now I divide both sides by 2 and I get x cubed is equal to 432. X cubed, not x squared. Okay. Now, now I'm going to take the cube root of both sides. So that means x equals the cube root of 432. Now this, now if you notice, you can kind of go through this, but this is divisible by 8. Okay? So you get 8 times 54. Okay? But 54 is also divisible by 27. right, which is the cube root of 3. So you can write this as the cube root of 8 times 27 times 2. Both of these, 8 and 27, are perfect cubes, which means now I can write this as 2 times 3. So that comes out and becomes 6 times the cube root of 2. Okay, so that's what I have so far. So there's my x value. Okay, so what is my corresponding y value? Okay, well, let's do that. Well, y equals what? 216 divided by x squared. Well, what's x squared? It's going to be 6 times the cube root of 2, quantity squared. Okay, so that gives us 216 over 36 times the cube root of 2. Okay, now, here's where, oh, this is squared. So this whole thing is quantity squared. Okay, so now here's where I need a cube here to undo this because I don't want any roots in the denominator. So I'm going to multiply the top and the bottom by the cube root of 2. And the only reason I'm doing that is I'm rationalizing, not 3. I'm rationalizing the bottom. So all I need is I need one more cube root of 2 to get cube root of 2 to the third power to undo it. So that's what I'm doing here. So now what I'm going to get is this will give me 216 times the cube root of 2 over what? 2 times 72, right? And then this 72 goes into 216 3 times. So that'll give me 3 times the cube root of 2. And there's my y value. 3 times the cube root of 2. So now I've got my x and y. Okay, so let's go back up to here. Let's go over here. So now x equals, where is it? 6 times the cube root of 2. Y equals 3 times the cube root of 2. Okay, so there's my two dimensions. So these are the two dimensions that give me so this is my critical point, right? So this is where my critical point happens, right? And so there's my x and y. Okay, now, and so since here's the thing, since this is the only critical point of S prime, I should say, or a critical point of S, I should say, it has to be the absolute minimum. So the absolute minimum must occur here. So this is going to be the corresponding y dimension, or height of the box in this case. And so now we found the two dimensions. So now let's find the surface area. Okay, so now if we plug this in, right? Well, in fact, we can just plug x into here and we have it. So I don't even need y. So S is going to equal to 864 over 6 times the cube root of 2 plus 6 times the cube root of 2 quantity squared. And if we put that into our calculator, we get approximately, well, actually we can, we can just get the exact answer. They don't ask us for an approximation. So we'll just get the exact answer. So we'll just simplify this. So this is going to be, how do I want to do this? $864 Okay, so let's just simplify this. So this is going to go into 864 times it's going to be 1 and 4. 144 over the cube root of 2. And this is going to be plus 36 over the cube root of 2 squared. Okay, so I'm gonna get a common denominator here. So let's make this 144 plus, so this will be 36 times 2 over the cube root of 2. Which is then going to equal hold on. So 144 plus 72 is going to be 216 over the cube root of 2 okay. And so now what I'm going to do is I'm going to multiply, again I got to rationalize the bottom, so I'm going to multiply the top and the bottom by the cube root of 2 squared. Okay? And so this is going to give me 2 on the bottom, right? So just bear with me. So this is going to give me 216, and I'm going to get 2 on the bottom because I've got cube root of 2 here, and I've got 2 more cube root of 2's here, so that's going to give me the cube root of 2 cubed, which is 2. And then I'm going to end up with the cube root of 2 quantity squared in the numerator. So this is going to give me 108, and then all I have to do is just bring the square inside and just make this the cube root of 4. And so this is the exact surface area. So this would be square units. Okay? And since it's inches, we're going to do inches squared. Okay, so always remember to put your units in there. If units are given, units should be in your answer. Okay. And of course, these would also be inches as well. So here are the dimensions, and that's the surface area. Have a great day.